This is where we left you with this groovy posterizing effect. Let's call this lesson number 2, fixing the circuit. The circuit, very cool design, if I do say so myself. Very simple, remarkably simple. How was it so simple? It was so simple, it used only 2 comparators. Remember the comparators? Our friends, the comparators. And we drew them like this. And we showed that they pulled to the ground. And literally, we just summed their outputs together and it went out and made video. Cool! Here's the bad part. Was the input part. Very unmanageable. We had these little pots. They were tiny little pots, little screwdriver pots. And they went all the way from the ground, all the way up to +5. And I mean, where you needed them to be was right in the middle. It was like you were cracking a safe. And if you didn't have a scope, it was still hard to find. If you had a scope, it was very hard. Because you had to get the sync picked off before anything could happen, but you had to have the video picked off in order to see that you had the sync picked off. Nasty. Very nasty. Cool and simple, almost impossible to use. So we got to fix that. Well, let's draw your kind of typical sort of video. We want to pick off the sync. We want to pick off some video. What happens if we don't know where that is? Big trouble. A funny thing happens with video. Typically, unless it's good old-fashioned perfect video, if it gets really, really big, it tends to push down. Really, really big and push down. If it gets really, really small, it tends to pull up. So that is to say, if it were like black, very dark, it is, I'm going to do the dotted green line for the ground. It would be like here. Another color, let's go orange. I haven't used orange yet. Suppose video's really bright. What happens? It tends to push down. Because in a minute we'll learn about capacitors and how we get the average and all that, but just stand by and just know that this is a problem. Because we're not picking off sync anymore. If that video gets big, we're screwed. Okay. We are living in a 5-volt world so far. Our circuit has to stay above the ground and below +5. Everything has to happen in here. Okay? And that was part of the problem. Which is one reason I said we have to use those Radio Shack distribution amplifiers, because they pick the video up to where we can play with it. Okay, but we want to make it someplace precise. And we're going to use something called a clamp. In our case, a soft clamp. We want to clamp the video to something. Well, if you're going to clamp, you better have something firm to do it on, okay? You can't be clamping on something soft, because that'd be a clamp. In the future, we're going to clamp on the ground. It's a nice place to clamp to. But the ground is at the bottom. We can't really use the clamp at the bottom. We have to use the clamp someplace in between, because I got to clamp that video somewhere as we can get at it. So we need an in-between. How are we going to get our in-between? We're going to make a little mini rail, I call it, okay? Like a little power supply, somewhere between the +5 and the ground. There is a fantastic little chip. It's more like it looks like a transistor than a chip, in fact. And it's called the LM317. Nothing to do with the LM311, it's just a number. And I draw it like it looks. And I do that because when I put it on the breadboard, I really don't want to screw up. I'm dealing with power here, and I just don't want to get it backwards and messed up. And it's kind of laid out squirrely. And what I mean by that is the input's over here, +5. And the output's here in the middle. That's kind of weird. You see, I want to draw it facing me. And this last guy is the ground. Now, this guy will do funny, cool stuff like any voltage you want. any positive voltage you want. We only want one. We need it to be one someplace between 0 and 5. I'm just going to put a resistor right down here to the ground. I'm going to nice low 100 ohms. And this guy with no other components is going to give me 1.25 volts. That's going to be our mini rail, okay? So next time I go up, I don't have to go up to just +5. I can also go up to 1.25. That's going to be our other little rail, okay? You sort of figured every time I went up it was 5. Nah, it can be whatever I want. But it is above the ground, so I tend to make it go up. All right, now that we saw that guy, he's going to help us. We need our mini rail. Now, let's talk about a capacitor. What's a capacitor do? A capacitor passes AC. What is AC? Alternating current. Up and down, all around, alternating. What does not get through a capacitor? DC. What is DC? DC is that where I am. I can vary, but that's the DC. Well, I don't want that DC. I want to do my own DC. Keep your DC to yourself. So that capacitor is going to help us get rid of that DC. Okay, but we need another component. But stop, we need another component. This other component is a diode. A diode. It's drawn like this. That helps that it's drawn like that because it tells you kind of what it does. It allows current to flow that way and not that way. Okay? Those two things, those three things, the little mini rail, the capacitor, and the diode are going to help us put our video where we know where it'll be, or we can get a handle on it. Okay, how are we going to do that? Well, let's go back to the video. The video came in, as you'll recall. This is my little schematic for like an RCA connector, but I also use it for a BNC connector. I just showed that the outside is a ground and the inside has the signal. I made it up myself, I think. First thing you always see is the good old 75 ohm terminating resistor. Anytime the video is coming in, it goes 75. Anytime video goes out, if you're playing by the rules, we'll get back to the rules. All right, so we don't know where this DC is. We don't know, we don't care anymore because we put in a capacitor. Yahoo. Well, I could just say, you know what? I have this cool little new mini rail. Let's just put a resistor up to it. Plus 1.25. All right. So now, no matter where the DC was here, I now know that our video would sort of be on average 1.25 volts. Cool. Oh, we don't want it on average. We want that sucker to rest somewhere. In the future, we'll be resting on the ground. We don't have a ground here. This is our little fake ground, our little mini rail in the middle. We're going to rest our video. How are we going to rest our video on that? Well, enter the diode. What we're going to do is we're going to put this diode here. And it's going to go up to our new little mini rail, 1.25 volts. And we're going to pull down. Pull down. What does that mean? If that diode turns on, oh yeah, I left one part out. Funny thing about a diode, yes, the current can only go this way. But once you turn it on, the voltage across it is going to be 0.7 volts. That's confusing. Why didn't you say that earlier? Because I wasn't thinking clearly. And it gets back to the fact that diodes and transistors and LEDs, they're all current devices. It's time for me to back up again? Sure, why not? Ever lit up an LED? Let's draw LED red here, because it's a red LED. I draw my LEDs like that, because there's photons shooting off into space. And typically, an LED has to have a resistor. Why? That LED, depending upon which one, I'll roughly just say it's about 2 volts. When you turn that sucker on, it's 2 volts. Not 1 volt, not 5 volts, but 2 volts. In other words, It's going to go on, it's lit up, that voltage will stay put. As I vary that resistor, it's going to get brighter or darker, but it'll still be 2 volts across it. All right? All diodes are like that. Once you turn them on, they have a fixed voltage across them. That's it. If you pull too hard, you'll blow it up. Well, they don't explode, but they fail. They open. Okay. So, sorry for that diversion, but here we are. That diode, once it's turned on, is going to have 0.7 volts across it. And no more. I can pull harder and pull harder and pull harder. What that sets for us is a nice little perch, a nice little ground, a little place to sit. So this video now, it's going to be resting on that. What is it? 1.25 minus 0.7. Good Lord, he couldn't have picked like a round number. Sorry. It's 7 for 5. Let's say it's what is it? 0.55. It can't go lower than that. And we're going to be gently pulling down all the time. So it's going to rest. That sucker is going to rest on the ground. Okay? But we don't want to pull very hard. So we're going to make this a pretty high resistor. We're going to make that 100K. We're going to make this capacitor a 1 microfarad. All right? And that'll do a good job of soft clamping the video. Okay?